In this video, we will talk about basic BGP configuration, guys. Even the main functionality of BGP is routing between different autonomous systems. It can exchange routes within same autonomous systems as well. So there are two main BGP protocols, and they are eBGP, which is used for routing between different autonomous systems and exchange routing information between external networks. And we have the iBGP that is used for routing within the same autonomous systems. It exchanges routing information among routers within a single AS. So the BGP neighborship can be within the same AS or between different AS, as I told you. But the main functionality of BGP is just exchanging routes between different AS. I just want you to be aware of something which is important. In BGP, neighbors do not have to be directly connected to each other, guys. So let's start with eBGP adjacency. So eBGP adjacency refers to the relationship established between BGP routers in different autonomous systems. Okay, here routers establish an eBGP session by forming a TCP connection on port 179 and exchanging BGP open messages to negotiate the parameters. So this one, eBGP, requires routers to have directly connected IP addresses or an intermediary network that allows communication between them. So most of the time you will see that eBGP neighbors are directly connected. So if you can check the example on the screen now, for example, router C and router X, they are in different AS and they are eBGP neighbors. Okay, for example, router D and router Y, they are in different autonomous systems, right? And they are the eBGP neighbors. On the other hand, iBGP refers to the relationship between BGP routers within the same autonomous system that allows them to exchange routing information. Okay, so iBGP sessions are established very much similarly to eBGP using TCP port 179, and routers exchange BGP open messages to negotiate session parameters. Traditionally, iBGP requires that all routers within an AS have a direct iBGP session with each other to ensure consistent routing information. And this is known as the iBGP full mesh. Okay, there are some considerations and caveats about this topic, iBGP full mesh, and I will tell you in our next sessions how we can overcome iBGP full mesh as well. And iBGP routers share routes learned from eBGP peers with other iBGP peers within the same AS. So iBGP routes are not advertised to other iBGP peers unless they are redistributed via iBGP sessions. This is very important, guys. And neighboring routers configured with the command neighbor must be able to access each other before the BGP configuration, and an IGP is usually used for this purpose. So what I'm trying to say, for example, I have my router A in here and I have my router C in here. So those two can become an iBGP neighbor. Okay, here there is nothing like these routers need to be directly connected. Okay, even they are not directly connected, router A and router C can become a BGP peer. But the only thing that you need to know is there should be a reachability from router A to router C. So how I am achieving this is most of the time there will be one IGP running within this AS. So for example, there is an OSPF, first of all, helping me to reach from router A to router C, okay, Once this reachability is there, only then I can go ahead and configure IBGP for this router A and the router C. Okay, so the IBGP is usually used in conjunction with an IGP such as OSPF, and again, there is nothing like neighbors should be directly connected. Even they are not directly connected, you can establish an IBGP peer. During the BGP session establishment, we have mainly 5 steps. First step is idle. That is the initial state before any BGP session attempts. Here the router is not actively trying to establish a connection. In connect state, the router is attempting to establish a TCP connection with its BGP peer, and if it is successful, it will transition to the open send state. In open send state, the router has sent an open message to its peer and waiting for an open message in return. So the open confirm means the router has received an open message from its peer, sent a keep alive message, and is waiting for a keep alive response to confirm the session. And lastly, we have the established session. Here the BGP session is fully established and the routers can exchange routing information anymore. Now let's talk about how I can configure a BGP peer. Okay, so the BGP neighborhoods are manually configured, guys, and the remote AS command displays the AS number of the neighbor on the remote system. Okay, so I have mainly 2 different configuration examples in here. The first one is the eBGP one, the second one is the IBGP one. So the eBGP peering is between router 5 and router 4. Where is my router 5? Router 5 is in here, router 4 is in here. Are they in different autonomous systems? Yes, of course. So that means I can go ahead and create an eBGP peering between router 4 and router 5. So how I'm doing the configuration? Let's look. On router 4, I'm going to router BGP and AS number of router 4 itself. Okay. And then I'm going ahead and defining my neighbor manual. Neighbor IP address 10.145.2, that is the IP address of router 5's this interface. And I'm defining the remote AS and the AS number of router 5. Okay, so I'm doing the same thing on router 5 as well. Router BGP and the AS number of router 5 itself. Then I am defining the neighbor and the IP address of the peer, followed with remote AS and the AS number of my router 4. Okay, this is how I'm going ahead and creating my eBGP neighborship. Okay, so most of the time, guys, the eBGP peering will be directly connected. Okay, and it should be directly connected. Okay, so but for this scenario it is fine. But what if this router has a loopback address which is 4444 and this router has another loopback address which is 5555? And what if I would try to create an eBGP peering by using my loopback addresses? Then the configuration would change in this way. Okay, so for example, in router 5 I will still type this, but the neighbor will become 4444 this time, and for router 4 the neighbor will become 5555 this time. Okay, but In this case, the router 4 and the router 5 is not directly connected for these loopback interfaces. But eBGP neighborship should be directly connected. So what I'm doing in this case, we have one command eBGP multi-hop and 2. Okay, so I'm defining this command as neighbor and the like this, let me neighbor 5555 and followed with eBGP multi-hop 2. Okay, that is the configuration that I need to do on router 4 to establish a BGP peering with router 5 over the loopback interface. Okay, when it comes to the router 5, what I will define, I will still define this one, neighbor 4444 remote AS and 55,000. Okay, and I will do one more thing, neighbor 444 4444 followed with eBGP multi-hop 2. So by the way, what does it mean? That means in router 4 I have my loopback interface, and from my loopback interface, if I need to reach the loopback interface of router 5, I need to pass 2 hops, okay, which is this one and this one. So this loopback is 2 hops away from my side. Okay, so story short, most of the time this loopback configuration will not be something that you are facing with for eBGP neighborship, but just in case you face with, this is the command that you need to use. You need to go ahead and use the eBGP multi-hop command if you just want to establish a neighborship by using the loopback interfaces. Otherwise, if you just go ahead and use these interfaces, since they are directly connected already, there is nothing to worry. And in the second configuration, I am doing an iBGP configuration. Okay, so between router 4 and router 1 this time. What I'm doing is just again I'm typing router BGP and the AS of the router that it belongs to. This time remote AS will be same with this AS number because the iBGP neighborship is established within the same AS as we know. Okay, and please pay attention that router 1 and router 4 are not directly connected in this case, right? So how I'm doing the configuration in this case, again I'm typing the neighbor keyword followed with 1111 and with remote AS 55,000. Okay, and I'm typing the neighbor 4444 followed with remote AS 55,000. So by the way, 1111 is the loopback interface of this router and 4444 is the loopback interface of router 4. But there is one issue in here, okay? Remember, I have told you, router 1 and router 4 can be an iBGP peer and there is no need that they need to be directly connected, okay? And router 4 can reach router 1 in 2 ways. The first way is from here and the second way is from here, okay? So mostly in iBGP, the peering is done through the loopback interfaces. Okay, why? Because if I do the peering from my, actual interface itself, and for somehow if this link goes down, even if I have an alternate path to reach router 1 from router 4, which is this one, the BGP neighborship will fail because of I am doing the peering by using this IP address. So that is why I always try to do my IBGP peering over the loopback interfaces, because loopback interface is always up, right? So it never goes down. Even this link goes down, my loopback interface is up, and since I have reachability still to router 1, my BGP peering will remain up. So there is just one more command that I should not forget for my IBGP peering when I'm doing the peering over the loopback interface, is that neighbor and the neighbor address followed with update source loopback 0. Okay, so same I will apply to my router 4 configuration. Again, neighbor 1111 update source loopback 0, and I will do the same thing for my router 1 configuration, and I need to apply update source loopback 0, neighbor 444 update source loopback 0. I'm very much sorry for my bad writing. I will try once again. Update source and loopback 0. Okay, so it seems a little bit better, not the best one of course, but I think it's better. So story short, what we need to learn regarding this slide and regarding these examples. First of all, the eBGP peering must be directly connected. Okay, if you just want to do an eBGP peering by using the loopback interfaces, which is a very rare case, you need to use eBGP multi-hop 2 command on both routers. So the second thing that I need to be aware is IBGP peering is not required to be directly connected. Even I can go ahead and create an IBGP peering between router 1 and router 4 as I showed you. But IBGP peering is most of the time over the loopback interfaces. I explained why. And what I need to do when I'm doing the configuration, I need to use the update source loopback command. Okay, so that is the whole summary of this slide actually. I hope it was clear. If not, just use the Q&A section and ask me the question. In previous slide, I showed you how we are configuring the neighbor. Okay, but the BGP configuration has really two parts. First, you need to, define your neighbor, and then secondly, you need to advertise your networks. To advertise networks in BGP, we have two ways. The first way is by using the network command, and the second way is by using the redistribution. So for example, let's have a look to router 5. Router 5 is connected to some other local area networks, okay? And they are 50.110/24, this one, and 201.110/24, 2, 3, 4, 5, 6, 0/24 as well. Okay, so in here, if I just want to advertise this network, for example, this network first, I can go ahead to router 5 and I can try to advertise it by using network command. Router, BGP and the AS number, and I can go ahead and type only the network 50.0.0.0. Okay, so that is how I am doing the advertisement by using network command. But there is an issue again in here. If I go ahead and do the advertisement like this, it will advertise everything, okay? Everything starting with 50.0.0.0. So it will advertise everything in this case. The correct usage of this command is really network 5000, not 5000. Sorry, let me type in here. Network 5110 mask 255 0. Okay, so the correct usage is like this. So basically how I can change this network 5110 followed with mask keyword and the subnet mask that you are seeing in here. Okay, so this is how I can use network keyword to advertise a subnet from router 5 itself. The second method is the redistribution. So as I told you, router 1 has connection to these local area networks as well, starting from 1.0 till 6.0. So how I can advertise these first 4 subnets, but I don't want to advertise these 5 and 6 subnets. How I can achieve this? Of course, I can use the redistribution by the help of my great access list, on top of that putting a route map. Here is how I'm achieving this. I am defining an access list 50, and matching the subnets that I want to advertise, which are 10, 20, 30 and 40 subnets. Then I am creating a route map. Okay, route map, the name of the route map is filter permit 10. What I'm doing with this route map is I am matching the IP address range defined with ACL 50, which is 10, 20, 30 and 40. Then I'm going into my BGP mode, router BGP and the AS number. On top of that, I'm doing this redistribution configuration. Redistribute, connected, followed with route map keyword and the route map name. So all this configuration you are seeing in here will help me to advertise 1, 2, 3 and 4 networks. 201, 1, 10, 20, 30 and 40 will be advertised by router 5. I'm not gonna go ahead and advertise these 50 and 60 subnets. Okay, and this is the usage of redistribution in BGP when I am advertising the networks. Mostly, guys, the network keyword will be, fair enough, okay, but there will be some cases that you need to use the redistribution as well. So keep in mind the both options and be aware of them. Most of the times, again, the network keyword followed with the mask will be enough for you, but pay attention, there is redistribution option also. As I told you before, in BGP we have something called the BGP table that displays all routes learned via BGP, including the prefix information and the path attributes. So the command I'm using to view the BGP table is show IP BGP. When I run this command, you will see some information like in the screen. Okay, and you will see some symbols in here. You will see like greater than, you will see the asterisk, and you will see greater than with asterisk. Okay, there will be some symbols, and you will see the local preference, weight, and the path information as well. But what I want you to be aware of mostly is these symbols. So guys, these symbols indicate various states and attributes of the routes. Okay, so for example, I have my greater than symbol. So the greater than symbol is used to indicate the best or selected route for a particular destination. So when viewing a BGP routing table, if a route is marked with greater than, it means that this route is currently the preferred path that BGP has chosen for the destination. Okay, and I also have the asterisk. So asterisk symbol is used to denote a route that is present in the BGP routing table, but it is not the best route. So it indicates that the route is being advertised by BGP, but it is not the currently preferred path or the selected route. Okay, and I have a combination of both, okay, greater than with the asterisk. That means a route that is both the best route and it is also installed in the local routing table. So it signifies that this route is the preferred route and is being used for forwarding the traffic. So in summary, guys, this one greater than means the route is the best route. Asterisk means the route is in the BGP table but not the best route, so it's not installed in the routing table. And the combination means the route is the best and it is installed in the local routing table. Okay, so for example, for this network 10.254.0.0 network, okay, it is being advertised from this peer as well as this peer. For 11.4 peer, I'm seeing an asterisk, which means it is installed in the BGP table, but it is not the best route. Okay, so but for this peer 1.3, I'm seeing greater than with asterisk, which means this route is the best route and is installed in the local routing table. So pay attention to that. BGP table will include lots of routes with next hops coming from different BGP peers, but not all of them are installed to my exact routing table. What BGP does the path selection based on the multiple criteria that we have discussed before, and whichever route fits the best path, then it goes ahead and installs it to exact routing table, and it is shown with greater than and asterisk. So another command which is useful exactly for BGP peering troubleshooting is show IP BGP summary. This command will show you what are your BGP neighbors, the AS numbers of the peers, how many messages shared with these peers, how long the session has been up, and the number of prefixes exchanged between this particular neighbor. So BGP next hop self is a command used in BGP configurations to influence the next hop attribute of BGP routes. It mainly sets the next hop IP address for BGP routes to the IP address of the local router's interface. So this is particularly useful in iBGP scenarios to ensure that all internal routes use the same next hop address. So we need to know something about in here, which is very important. An eBGP peer, guys, it changes the next hop on advertised router. On the other hand, an iBGP peer that does not change the next hop address on advertised router. So for example, router 5 is advertising some routes to the router 4, right? For example, this subnet. So this information will be received on router 4 and something like, hey, there is some network with router 5 with 5110, and next hop is router 5 itself. The next hop is router 5. Then when router 4 is advertising this information to router 1, it does not change the next hop address on advertised route. So it will say router 1, hey router 1, I have these routes with me and the next hop is router 5. But router 1 is not aware of router 5, right? That is the problem in here. So next hop self helps me to resolve this issue, okay? Because the IBGP peer does not change the next hop address on the advertised router, and this is causing the issue. So what I'm doing, I'm going into my BGP AS and I'm typing neighbor 111 and next hop self, okay, which means router 5 is sending me still these routes regarding the 5110. This time when I'm advertising it to my router 1, I am saying router 1 that the next hop for this subnet is myself. It is router 4, okay? So router 1 is aware of router 4, right? That is its neighbor. So basically the next hop will be 4444 in this case. So router 1 will say that if I need to reach somehow to these subnets, my next hop is 4444, which is someone that I really know well, and that is router 4. Great, amazing. So that's it from my side, guys. Thank you so much for listening to me.